Hey, welcome to Dr. Pat TV. We are looking at part two of definite integrals. So basically, here's an example of how we could actually use this mathematical concept, this fundamental theorem of calculus, to do some calculations for something to do with business. Okay, so what we've got here is we've got a formula for marginal cost. That's telling us basically how our cost is changing when we're producing more and more, in this case, my woolly beanies. And so what we want to find here is we want to find the change in the cost, that total cost, the change in the total cost if we increase production level from 110 to 160 beanies. What is going to happen to our cost? Okay, so we've got a formula. It's marginal cost. Now, mathematically speaking, as a math geek, when I see MC from the business people, I'm thinking C prime because it's the derivative. MC is the derivative. Marginal cost, how things are changing. The cost is changing, and that's C prime. That's the derivative. So if I'm starting with the derivative and I want to figure out how the total cost is changing, then basically what I'm looking at is integration. I am doing the antiderivative and then some calculations. So we're going to be doing the fundamental theorem of calculus here because we are starting with the derivative with this marginal, and then we'll go the opposite way. Okay, so now what do we got to calculate? Here's what we've got, putting it all together. I want to take the antiderivative of the marginal. I want to take the antiderivative of the derivative. Okay, so that's where I've got the formula there. So there's my marginal. We're going to take the antiderivative, the integration. Now, what do I have here? For my limits of integration, I'm going from 110 to 160. So this calculation is going to calculate for us the total change in cost going from 110 to 160. Okay, so then basically we just got to do our steps to do this calculation. Our first step to do the calculation is to take the antiderivative. And this is looking like a nice straightforward power rule. We're going to have the antiderivative of 5 is 5q. And then when you've got a q there, remember that's q to the first. So we've got that power rule that says add 1 to the power and then divide by the new power. So that's why this 0.002 turned into a 0.001. Okay, because we had to divide by that new power. And then we have this vertical line right here. That just basically is just a reminder for us that we've done the antiderivative, but we still need to do the calculation. We still need to do the substitution and then the calculation. So then what we're going to do is we're going to take 160, going to plug 160 into our antiderivative, and then we're going to plug in 110 into that antiderivative, and then we take the difference of those results. And so when we get that, we're going to get something like 236.5. So basically, our cost is going to increase 236.5 units. I'm not sure if this is dollars or it could be thousands of dollars, whatever it may be. But it's looking like we're going to increase our total cost by $236.5 when we increase from 110 units to 160 units. Hey, hope this helps to get to see an example of how we could actually use this fundamental theorem of calculus. Thanks and have a good day.